Today we'll discuss about some numericals of pulley. Okay, so in machine chapter there are two parts. One is lever, another one is pulley. So we have already discussed the numericals of lever. So here today we'll discuss some numericals of exercise 3b. Maybe it is possible that whatever the numericals I have done here, maybe it is not matching with the question number is there in my book with your book. So you will see, you will just listen the question properly, because if I write the question all the time then it will take much time. Better I will mention the question number. I think it will be same. Okay, so first we will go for numericals number 4. Okay, so numericals number 4. Here in numerical number 4 it is told a block and tackle system has 5 pulleys. If an effort of 1000 Newton is needed in the downward direction to raise a load of 4500 Newton, then calculate the mechanical advantage, velocity ratio and the efficiency of the system. Hope the numericals are same. If it is not same also, then the things it is written we have to write down. First information is given, number of pulleys. So number of pulleys it is given, it is 5. So by this statement what we can understand, if the number of pulleys are given, we can understand the velocity ratio of that pulley will also be 5. Okay, so as the number of pulleys are given, so we can able to find out the velocity ratio. Effort, the value of effort it is given 1000 Newton, and the load it is given 4500 Newton. Okay, first question is question number 1, mechanical advantage. We know mechanical advantage equals to what? It is load by effort. Say load is given to us 4500, effort also we know 1000, so it is 4.5, and we know as mechanical advantage is the ratio of two same physical quantities, there shouldn't be any short of unit. Number 2, what is the velocity ratio? Velocity ratio we have already got, that is 5. And number 3, it is asked what is efficiency. Efficiency equals to, we know that mechanical advantage by velocity ratio into 100. We have done it 100 because we want to express the efficiency in percentage. Okay, so now we'll put the value. What is the value of mechanical advantage here? Mechanical advantage is 4.5. What is the value of velocity ratio? That is 5 and 100. So it is 0.9. So it is 90%. Okay, so we can say that efficiency is 90%. Okay, next numerical is question number 6, and here I have written the numerical because in new version the numerical is little different. That means in your book the numerical is little different, and that's why I have written it. What is the question? Please read it first. A pulley system has a velocity ratio 3. That means whenever we have to do the solution, the first information is given to us, that is the velocity ratio, that is 3. The efficiency, that is eta, that is given 80%. And first it is told draw a level diagram of the pulley system. So velocity ratio is 3. That means we can say that number of pulleys, that is equals to also 3. If velocity ratio is 3, the number of pulleys is also 3. So we have to draw a block and tackle system of pulley 3. So it is very easier to do. So 3 means we have to divide it 2 plus 1. That means 2 block and 1 in tackle. You already know the number of pulleys in block should be more or equal to the number of pulleys in tackle. So here we have to draw the threads. Okay, so keep one thing, remember that I have told several times that the thread you have to make that is straight. Okay, so here I have drawn it. I'm trying to draw, but it is little bit of bend, so it shouldn't be bent, it should be straight. So here in this direction you have applied the effort, the tension will apply in this direction, and here the three strands are there, 1 2 3, and everywhere the tension is acting upward, T T T. The tensions are same because it is only one thread. Okay, and the load, if it is the load, it is acting downward. So this is the level diagram of a pulley system, where we have to mention this portion, it is block, and this one it is tackle. Okay, so from here, as it is not told to show any calculation, so we don't need to show. First question, question number A, we have to find out the mechanical advantage. We know that efficiency eta equals to mechanical advantage by velocity ratio into 100. We have to find mechanical advantage. So mechanical advantage equals to eta into VR by 100. Okay, so what is the value of eta? It is 80. What is the value of VR? It is 300. Okay, so 8 3s are 24, 24 by 10, it is 2.4. Okay, so mechanical advantage is 2.4. Now the next question is the effort required to raise a load of 300 Newton. How much effort is required? Question number B. So we know that mechanical advantage is equals to load by effort. Okay, and here effort should be load by mechanical advantage. The value of load is given to you, that is 300 Newton. Mechanical advantage you have calculated, that is 2.4. And now if I take this point, so here will be 1 0, so 12, 1500, 6, and then it should be 750, 3, it will come 375, I think. Okay, 375, and 375 means 3 1s are 1 2, 3 2s are 6, and 3 5s are, so 125. So it is 125 Newton. Okay, so the value of effort, that is 125 Newton. Okay, so this is the numerical of question number 6. Now we'll go for the another numerical, that is question number 8. See, I'm just trying to do that type of numerical which seems to be little harder for you. But here if you see, all the numericals are very easy. So I'm just trying little harder numericals that I will help you to do. But I'm telling you, the question number 6 in your book, maybe it is different. So if it is different also, I think you can able to do it by see the pattern of this numerical. Next we'll go for question number 8. So question number 8 I will not copy, because I expect that, and I know that, I think it is same in your book also. So that one I will not copy. What question is there in question number 8? Let's see. So question number 8, it is told that figure 3.34 shows a block and tackle system of a pulley is used to lift a load. Okay, so the drawing is given to you. Okay, so it is a 4 pulley system. Simple thing, it is a 4 pulley system. So from this diagram we can conclude that here the number of pulleys are 4. Okay, so we have to mention here number of pulleys equals to 4. Now we'll go for the first question. How many strands of tackle are supporting the load? If I have drawn the diagram, it's no need to draw, but then also I have drawn this. Okay, so here it is first pulley, then it is second, so our block is completed, and then we will go for the tackle. Okay, so this one is also done. Oh, so this is our tackle, and here the load is effort okay, so almost we have done it. So effort will apply here, the tension will apply here, 1, 2, 3 and 4, and load it is acting downward. So first question is, how many strands of tackle are supporting the load? So strand means 1, 2, 3, 4. These are known as strand. Okay, so how many strands are there? So we can say the number of strands, that is equals to 4. Okay, so 4 strands are needed to support the load. Draw arrows to represent the tension of each strand. So we have already drawn. Okay, what is the mechanical advantage of the system? If I am talking about the mechanical advantage, see, as here the efficiency is not mentioned, we have to assume that let the efficiency is equals to 100%. Then only we can say that from diagram effort is equals to tension if it is in equilibrium, and load is equals to 4 times of the tension, and their mechanical advantage equals to 4T by T, that is 4. So it is only possible that the total tension is used to lift the load only. Next question. When load is pulled up by a distance of 1 meter, how far does the effort end will move? It is told if the load pulled up by a distance of 1 meter, how far does the effort move? So question number D. So it is question number C. Question number D is told that displacement by load, that is denoted by DL, it is 1 meter. It is asked that you have to find out displacement by effort. We know that velocity ratio equals to displacement by effort by displacement by load. So here displacement by effort equals to velocity ratio into displacement due to load. Velocity ratio is 4, displacement due to load is 1. So it is 4 meter. That is the displacement due to the effort. How much effort is needed to lift a load of 100 Newton? Next. Okay, so it's question number E. How much effort is needed? We know mechanical advantage. So when it is told about effort or load, we'll just calculate it by mechanical advantage. We know mechanical advantage is equals to load by effort. Okay, so here if I want to find out the effort, so that will be load by mechanical advantage. What is the value of load here? The value of load is 100 Newton. It is already been given. And what is the value of mechanical advantage? That is 4. So it is 25 Newton. Okay, so this is the numerical number 8. Okay, just see, and better if you practice it by your own. Don't just copy it from here. My suggestion is you have to practice it by your own, and the video is there in your support, so you can see it anytime. Okay, now we will do the last one, that is question number 9. Okay, maybe I'm telling the question number in your book, that may be changed. Okay, whatever I have told it is 8, that may be in your 9. Whatever I have told it is 9, it may be in your 10. But questions whatever I have read, I think it is there in your book. Okay, except question number 6. Now go for question number 9. What the question is given here, first I will read and listen it properly. And if you are having any doubt, then you have to write it down in your copy. You can send it by WhatsApp, or you can call me. Question number 9, it is told in my book, the block and tackle system has the velocity ratio 3. So velocity ratio is equals to 3. It is already told. That means number of pulleys, that is also 3. What is told? Draw a label diagram of the system indicating the points of application and direction of load and effort. But simple thing is that we have already drawn it. Okay, so better you have to draw it in your copy. I have not drawn here because it will be longer. So I have not drawn the 3 pulley system because I have already drawn. I'll go directly to the first question. So before that, it is called the man can exert a pull of 200 kgf. So pull of 200 kgf means effort. It is given to you, that is 200 kgf. So kgf, it is the gravitational unit of force. Okay, so it is basically the force applied. What is the maximum load he can raise with this pulley system if its efficiency is 60%? Question number 1. Efficiency, it is told 60%. In how much load can be lifted? Okay, so before finding the load, I have already told to find the load or effort, we need to calculate the mechanical advantage. So here you see no mechanical advantage is given. So first we have to find the mechanical advantage. So we know efficiency equal to mechanical advantage by velocity ratio into 100, and mechanical advantage is equals to efficiency into velocity ratio by 100. So efficiency is told 60, velocity ratio we know it is 3 by 100. So 6 3 is 18 by 10, it is 1.8. So mechanical advantage is 1.8. Now we'll find out the load. We know mechanical advantage is equal to load by effort. So effort, it is given to you. So we have to find out the load. So load equals to mechanical advantage into effort. So mechanical advantage is what? 1.8. Effort, it is 200. So 1.8 into 200, it is simply 360 kg. Okay, simple thing, 360 kg F. Okay, now it is asked, question number B, if the effort end moves a distance 60 centimeter, what distance does the load move? Again the previous thing, question number B, it is told the effort end moves by 60 centimeter. So displacement due to effort, that is 60 centimeter, right? Displacement due to effort, it is 60 centimeter. We have to find out displacement due to load. Again we'll go for velocity ratio, that is displacement due to effort by displacement due to load. Next, displacement due to load equals to displacement due to effort by velocity ratio. Effort is 60, velocity ratio is 3, so it is 20 centimeter. So displacement due to load, it is 20 centimeter. Okay, so I think this numericals, if you see it properly, then you can able to do the rest of the numericals. So that is your task to complete all the numericals in your book, especially in Pulley chapters. This chapter is very important, and in next video we'll discuss the year questions or year papers separately for machine chapter. Thank you.